Hi, guys. Okay, let's look at chapter 6, homework questions on nomenclature, Lewis structures, on the shapes and polarity, and then the intermolecular forces. So first of all, I have listed all the questions from the homework on this page, and we are going to just do a review of those concepts from the book. So from your book, as you see in chapter 6, there are two types of bonds that they're talking about. One is the ionic bond and the other is the covalent bond. So the ionic bonds are formed when the metal and the non-metal join together, connect, and these are formed by the transfer of electrons. And the non-metals, when they combine, they basically share electrons, and in that case, covalent bonds are formed. So this is how they look. So when the ionic bonds are forming between a metal and a non-metal, the metal gives away the electrons and the non-metal takes in the electrons. So by this transfer of electrons, two types of species are generated. These ions are called the cations and the anion. The anions are the negatively charged, cations positively charged. Cations are the metals and the non-metals are the anions. Okay, now that forms the ionic bond and it's a pretty strong bond. Next, look at the covalent bond. Now that is also a strong bond. The only difference is that the ionic bonds, when they are in water, they break into ions. Okay, now let's look at these non-metals. Non-metals are formed by the sharing of the electrons. Now, they are formed by the sharing of the electrons because they're very close to meeting their octet. So we will look into this in a minute, but when they share the electrons, so how does the sharing happen? It's basically overlap of the electron clouds. So in that overlap region, the electrons that are shared are, found, and it helps meet with the octet or the nearest noble gas configuration. Okay, now let's look at a scenario where here is the 11 protons. 11 protons are of sodium. So sodium, 1s2, 2s2, 2p6, 3s1. So 3s1, as you see, is the valence shell. And there is only one electron present in the valence shell. Now, let's look at the scenario where that one electron, when it is lost, that loss of one electron creates another species, which is a sodium ion. Now, this sodium ion is positively charged proton, and that is the 11 protons are there in the nucleus. That is unaffected. However, the number of electrons are now one less. Now, look at the size. The size of a neutral atom where there are 11 protons and 11 electrons, the size is big, right? But the one loss of electrons makes the protons like more powerful, more dominant. So the electron cloud shrinks. And as a result, the atomic radius is smaller in the case of a cation. So the cations will always have a smaller radius than the neutral atom. Now let's look at a scenario with magnesium. Magnesium has 12 protons. Okay, so these 12 protons, the electronic configuration is 1s2, 2s2, and 2p6. Now, 2s2, 2p6, and 3s2. Now, this 3s2, these are the valence electrons. That means the electrons in the last shell. Okay, now what's happening here? In this case, the 12 protons found in the nucleus positively charged, right? 12 plus charges. And as many protons, there are as many electrons. So we see that there are 12 electrons also. So these 12 electrons and 12 protons balance each other. However, remember the 3s2, this is the valence shell, and there are two valence electrons in the last shell. So now what's happening? These two electrons, when they are lost from the last shell, the loss of two electrons gives magnesium 2 plus charges because there are 12 protons and there are 10 electrons. So 2 protons more, in other words, 2 plus charges more. So magnesium will have 2 plus charges. Okay. Now, why would magnesium lose 2 electrons? Because now magnesium has fully filled orbitals. 2s2 is fully filled and 2p6 is also fully filled. Fully filled orbital, that's one thing. Second thing is that magnesium now also has a total of 8 electrons, and that is the octet. Okay, and now if you look at also that 6 plus 2 plus 2, this 6 plus this 2 electrons plus the 2 electrons here. So these 6 plus 2 is 4 electrons, 10 electrons. So these 10 electrons, this electronic configuration match with that of neon. So they have the electronic configuration similar to neon, and neon is a noble gas. So this is the reason why magnesium will lose 2 electrons and sodium will lose 1 electron. So when it loses that 1 electron, it gets 10 electrons, and these 10 electrons give sodium a noble gas configuration of neon. Fully filled orbitals and 8 electrons in the last shell. 2 plus 6 is 8. 2 electrons, 8 electrons in the last shell. So that's the octet. It gets the octet and its noble gas configuration looks like neon. So that's how this is a very stable scenario for magnesium and calcium. Magnesium and sodium and all the metals, right? All the metals. So we are going to look into this further, but right now, just keeping it very basic, how the cations and the anions are formed. So here is a scenario of an anion formation. Here you see is chlorine. Chlorine is 7 valence electrons. Chlorine, yeah, 7, but chlorine has 17 protons and 17 electrons. Okay, now how are these 17 electrons placed? So this is the electronic configuration. 1s2, 2s2, 2p6, 3s2, and 3p5. Now, 1s2, 2s2, 2p6, that is 10 electrons, and that is the electronic configuration of neon. Okay, so that's one piece. That is the inner core. Okay, but inner core, leave that on one side, but focus on the outer core. I mean, the outer electrons. The outer electrons are in 3s2 and 3p's. So always keep this in mind that the valence electrons are present in the highest shell number. So here you have 3s2, 3p5. 2 plus 5 is 7. Okay, 2 plus 5 is 7. 7 valence electrons. Okay, so now we have chlorine with 7 valence electrons. Okay, now 7, it's very close. How do you show 7 valence electrons in chlorine? Like this, you know. So these are these 7 dots you see, these are the 7 valence electrons. So similarly, I forgot to mention this, for magnesium, there were 2 valence electrons. So we show them as 2 dots. Similarly, sodium has 1 valence electrons. We show it as 1 dot. Okay, so now back to chlorine. Now chlorine, sorry, where did it go? So here, chlorine, 7 valence electrons. It needs 1 more to get 18, right? To get 8 in the last shell. So when chlorine acquires that 1 electron, then it has 1 less proton, right? And it has 18 electrons and 17 proton. That is why the size of an anion is always bigger than its neutral atom, because that 1 electron needs to be placed in the orbitals around, and so the electrons have to move around a little bit. There's a slight repulsion in these electrons when a new electron comes in, and then they move around. So it's like, you know, spread out, and the nuclear pull also weakens. So because of that, the anion of chlorine, which is called a chloride, not chlorine, chloride anion or chloride ion, that is you know, it has a bigger or a wider spread. So it is bigger in atomic radius. Okay. Now, here's the thing that you look at this electronic configuration. Now, 1s2, 2s2, 2p6, 3s2. Initially, it was 3p5. So it was unfilled orbital. But after acquiring that 1 electron, it becomes 3p6. So with this 3p6, what is happening? Fully filled orbital. So not only is this number 6 plus 2, 8 octet, but it also has fully filled orbitals. Okay, so that's the deal why the atoms are going to, you know, lose or gain electron. But let's look at which ones are going to lose and which ones are going to gain. So by default, all the metals are going to lose electrons. So these are just some examples. Group 1A, lithium, sodium, potassium, rubidium, cesium, francium, all of them have 1 valence electrons in their last shell. So therefore, they will lose 1 electron and they will only have 1 plus charge. The name of the cation is the name of the metal itself. Similarly, group 2A, beryllium, magnesium, calcium, strontium, barium, radium. These guys also magnesium, calcium, barium, the names remain the same as the metals, but the valence electrons are 2. So in group 2A, 2 electrons are lost. And so we get 2 plus charges. Group 3A is a mixture of metals, non-metals, metalloids. So therefore, we are just focusing on the metals. In this case, aluminum is present, which is going to lose 3 electrons. So it will have 3 plus charges and the name remains the same. But on the other hand, look at the non-metals. Now these non-metals, now group 5A or group 6A and group 7A, all of them are very close to the noble gas in the same period. So what is happening here? They're so close to the noble gas that it's more electronically feasible for them to acquire electrons. So nitrogen and phosphorus will acquire 3 electrons, so they will get 3 negative charges. The name is changing. The name of nitrogen is nitride, phosphorus is phosphide. Similarly, group 6A. Group 6A will have 2 negative charges on oxygen and sulfur, 2 negative charges. The names is oxide and sulfide. And group 7A, the halogens, fluorine, chlorine, bromine, iodine, only need 1 valence electrons because they have 7 valence. They only need 1 electron because they have 7 valence electrons. So 7 valence electrons and plus 1 more gets them the octet. So fluorine, 1 negative charge, fluoride. Chlorine, 1 negative charge, chloride. Bromine, 1 negative charge, bromide. Iodine, 1 negative charge, iodide. Okay. So these are the very basic things about why the metals and the non-metals gain and lose electrons. Okay. Now, next is the charges. So now you look at this, that the metals, they lose valence electrons, especially in this case, group 2A, 3A, 1A, 2A, 3A. So lithium, sodium, potassium, all those. So lithium, all these, the ones in group 1A. So lithium with plus 1 charge, when it loses the electron, it looks like helium. Okay. Helium has 2 electrons, then lithium with plus 1 charge has 2 electrons. Neon has 10 electrons. Sodium has 11 electrons, but when sodium loses the 1 electron, it gets sodium plus 1 charge. Argon has 18 electrons and potassium has 19 electrons. When potassium loses 1 electron, it gets plus 1 charge and it has 18 electrons. So sodium 10 electrons, potassium 18 electrons, lithium 2 electrons with all those plus 1 charges, right, in the ionic stages. And similarly, rubidium, when it loses that 1 electron, it has the electronic configuration that of krypton. Now keep this in mind that these noble gases, helium, neon, argon, krypton, xenon, with respect to lithium, sodium, potassium, rubidium, cesium, francium, and also magnesium, calcium, strontium, barium, and aluminum, these are in 1 period above. Okay, so aluminum is in group 3 and neon in 2. So magnesium, similarly, sodium, magnesium, aluminum, all these are in group 3. So that's why when they lose that 1 electron, they begin to look like neon, which is in 1 period above. Okay, so that's the thing with them. But on the other hand, the non-metals gain electrons, then they look like the noble gas, which is in the same period. So nitrogen, oxygen, fluorine, they are in the same period as neon. So they are very close to neon in the periodic table, so they acquire 3, 2, and 1 electron so that they can look like neon respectively. Phosphorus, sulfur, and chlorine, similarly, they also acquire the number of electrons so they can look like the noble gas, which is near to them in the same period. Okay, so that's the thing. That's one thing with the non-metals and the metals. Okay, now we are going to look at these questions. From in this particular video, we are going to look at these questions, which are in your homework, and these are right now on page 189. So let's look at that. So we have homework 1.3. So in this page, actually, I have written the notes from my side also, the ones that I showed you, and these are in the tabular format. Okay, so all these are the tabular format. So I'm going to refer to these notes also for you so that you can, taking homework is easier for you. Okay, so now comes the question number 1. Okay, just give me 1 minute here. Okay, so now our first question here is state the number of electrons that must be lost to gain stable electronic configuration. Okay, and we are looking at gallium, cesium, and barium, and you should be doing other questions for more practice, but I will show you how to do these. Okay, so even though the question is not directly stating, that you should be using a periodic table, but you can, and you should. I mean, ideally you memorize the entire periodic table, but for now, let's look at. So what are the things that you need? You need to see where is gallium, Ga, gallium. So gallium is right here, Ga, okay, 31. And where is it present? It is present in group 3A. You see, gallium is in group 3A. So group 3A means what? There are 3 valence electrons. So what is, and it is a metal. Remember, all the metals, the blue ones, all the metals will lose electrons. So gallium is a metal and it is in group 3A and it can lose 3 electrons. And when it loses 3 electrons, it looks like the noble gas, the noble gas, which is in 1 period above. So when gallium loses that, gallium, because it's in 3D, so it's not going to look like, argon. It is actually, wait one second. Gallium has 3 valence electrons. Okay, so here's one thing. I'm forgetting one thing I forgot. Okay, gallium is in group 3. Okay, 4s2. So here's something. So let's write down the electronic configuration first for gallium. Then you can solve this. But for the 3 Ds, again, I'm sorry, I did not mean to say that gallium will look like argon because it is in 3D. So it is going to, because it has 3D, it is not in 3D, but it has 3D and it is in the 3A. So it is going to lose these 2 valence electrons from, 4s2. So let's look at this. So gallium is 31. Okay, gallium 31. So here is gallium 31. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10 and 4p1. Okay, so here's a scenario. Okay, yes, it will lose 3, but how? 4s2 is this, and then 4p1 is this. So, when you look at the periodic table, you're basically looking at the atomic number. And then what happens? When it loses, then what does it get? It gets a fulfilled 3D. It is left with that. So these are the 2 electrons from 4s2 and 3p1 that are going to be gone. So gallium will get +3 charge, and then it will have 31 protons and 3 less electrons. So this becomes 28. So 28, 29, 30, 31. So 28 electrons. Okay. So that's how it gets like 3 plus charges because 3 more protons are extra. So that's for the gallium. Now look at cesium. Okay. Let's look at the periodic table once again and look at where is cesium. Cesium is right here. Okay, and here in this case, it's easy because cesium is present in group 3A, in 1A. And because it's present in 1A, you don't have to do for the 1A, it's easy. 2A is also it's easy. You don't have to do the electronic configuration. I needed to show you there. But group 3A, generally 3 electrons are lost. Group 1A, 1 electron lost. 2A, 2 electrons lost. Okay, so cesium is in 1A, group 1A. So cesium will lose only 1 electron. So state the number of electrons that must be lost. So in this case, cesium group 1A, and that why it is going to form cesium +1 charge. Okay, so cesium will lose, so it loses the 1 electron to form that. So just keep that in mind that cesium has 1 valence electron and that one is lost. Okay, next look at barium. Now barium, where is barium present? Let's look at that. Now barium, look in the periodic table, look at barium. Barium is present in group 2A. So same story, group 2A, 2 valence electrons are lost. Okay, and so 2 plus charges. So here we have Barium is in group 2A, and that's how it will form barium plus 2 charge, because it has got 2 valence electrons. Okay, so that's the deal with 6.1. Let's look at 6.2. State the number of electrons that should be lost or gained to form the ions. So strontium. So once again, let's look at strontium. Where is strontium present? Strontium is present in group 2A. So how many electrons will be lost or gained? So it's easy. Strontium, group 2A, 2 valence electrons, and these 2 electrons can be lost. So we can show here that strontium, group 2A, so 2 valence electrons, and these are lost to form strontium, loses these 2 electrons, minus 2 electrons, to form strontium plus 2 charge. It's a metal also. Okay, look at phosphorus. Now here we have phosphorus. Phosphorus is in, here's the phosphorus. So phosphorus is present in group 5A. That means it has got 5 valence electrons, and group 8A, 8 valence electrons. So how many does it need to get 8? To make 8, you have 8 in its last shell. So it needs 3 more. So here we have phosphorus, group 3A. Okay. Oh, no, sorry, group 5A, sorry. Group 5A, and this has got 5 valence electrons. And that means, what does it look like? It looks like this: 1, 2, 3, 4, 5. And it will accept 3 more, so that it can have 1, 2, 3, 4, 5, 6, 7, 8. But anytime it does that, it will have 3 negative charges. Okay, so it will lose 3 electrons. Okay, now for the sake of practice, you guys need to do on your own. I can't keep doing all your homework questions, so the remaining ones you should do on your own. Okay, next, write the symbols of the ions. So if there are 9 protons and 10 electrons, so remember that every time it's the protons that determine the identity of the atom. The identity of the atom is determined by the number of protons. So let's look at these 2. So identity, that is actually the atomic number. So you're going to look at the atomic number in the periodic table. Okay, so that is the atomic number. So here we have, so we are looking at 9 protons. So 9 protons is fluorine. 7A, that means there are 7 valence electrons. 7 valence electrons. Okay, so let's do this. So here we are looking at, in the first case is the black one. Okay, so here 9 protons. So here fluorine has 9 protons, and they are saying that 10 electrons. That means that fluorine has acquired 1 electron. Write the symbols of the ion. So fluorine 9 originally will be 9, right? So fluorine has acquired 1 more electron to become plus 1 electron to become a fluoride ion. Okay, so symbol, the name is fluoride, IDE. Okay, anytime there is a charge, IDE. Next, 12 protons. Now here, once again, look at the periodic table and look for that element that has got 12 protons, or the 12th atomic number. And that is which one? It's magnesium. It is present in group 2A. Okay, so magnesium. So here is magnesium, 12 protons, right? So this is 12 protons, and it has lost 2 protons. That is why it becomes 10 electrons. So minus, so magnesium 12 protons, it has lost 2 electrons. That's why, so minus 2 electrons. So then it becomes magnesium with plus 2 charge. And this one will have 10 electrons. And this one has 12 electrons. Similarly here, this has 9 electrons, but now this has 10 electrons. Okay, so losing electrons gets a positive charge, gaining electrons gets a negative charge. Okay, all right, next is write the symbols of the ions. So now we need to write the symbols for the nitrogen, N, and radium. So what would be the symbol of the ions? Whenever we say ions, that means we are going to look at the charges. So let's look for nitrogen, first of all. Nitrogen, where is nitrogen present? Nitrogen is present. It's a non-metal, it's this side, group 5A. So what is the symbol for that? Group 5A, 5 valence electrons, needs 3 more. So that's why it becomes nitrite, right? To get octet. So nitrogen will gain 3 electrons so that it has, nitrogen has 5 electrons. So then it needs to have an octet. That's why it will gain 3 electrons. So it acquires the 3 negative charge, but the electrons are 8. So it's an octet, okay? Now let's look at radium. Radium is right here, radium, group 2A. Okay, radium. And so here we have radium in group 2A. That means there are 2 positive charges. So all the 2 plus 2 charge, all the group 2As will lose 2 electrons. Okay, so here we will see that radium is in group 2A. So therefore radium has 2 dots and then when you minus 2 electrons, then this becomes radium plus 2. All right. So that's the radium ion. Okay. So group 2A, group 3A. Okay. So we are going to stop here. We are going to end this video and we are going to continue with the remaining, questions, which are, I've already highlighted here. So we're going to look at the question number 13 and 15 in the next video. Okay. All right. Thank you.